Welcome to the 7th in a series of short videos titled Chemistry Made Easy. In this video, I'll walk you through one of the most basic and important concepts in chemistry. The concept I'm referring to is the mole. No, I'm not referring to the furry little creature with poor eyesight that digs holes and tunnels in your yard. I'm talking about a term that's frequently used to describe a specified number of atoms or molecules. A mole in chemistry is like the term dozen, which means 12 eggs or donuts or other items. Similarly, kilo describes 1,000 units of measure, as in kilometer or kilogram. Another example is mega, which means 1 million units of measure, as in megahertz and megabytes. A single atom or molecule is too small to work with in most lab experiments. So, moles are used to scale up the number of atoms or molecules to provide the chemist with a sufficient quantity of material to work with. At this point, you might be wondering how many atoms or molecules make up a mole? That's where 19th century Italian scientist Amedeo Avogadro comes into the picture. Avogadro discovered that equal volumes of different gases at the same temperature and pressure contain the same number of atoms or molecules. Avogadro is credited with determining the number of molecules per mole of material, although Johann Loschmidt was actually the first to do so. That number is 6.022 times 10 to the power of 23. This is known as Avogadro's number. The weight in grams of a mole of a substance equals its atomic mass. This provides a convenient way of tracking the quantities of reactants and products in chemical reactions. Let's take a look at water as an example. A water molecule, or H2O, consists of 2 atoms of hydrogen and 1 atom of oxygen. The atomic mass of hydrogen is 1 and the atomic mass of oxygen is 16, so the atomic mass of water is 2 plus 16, which equals 18. This means that 1 mole of water weighs 18 grams and it consists of 6.022 times 10 to the power of 23 water molecules. Now let's apply the mole concept to a chemical reaction between hydrochloric acid, or HCl, and magnesium hydroxide, or MgOH2. This reaction consists of 2 reactants and 2 products. As you may have surmised, it's an acid-base reaction. 2 moles of HCl react with 1 mole of MgOH2 to produce 1 mole of magnesium chloride, or MgCl2, and 2 moles of water, or H2O. This reaction involves only 4 atoms or elements, namely hydrogen, oxygen, magnesium, and chlorine. The atomic weights of these atoms are 1, 16, 24.3, and 35.5 respectively. These atoms are the building blocks for the reactants and products. We can determine the molecular weights of the reactants and products by adding together the atomic weights of their component atoms. The resulting molecular weights are 36.5 for HCl, 58.3 for MgOH2, 95.3 for MgCl2, and 18 for H2O. So, when we add the molecular weights of the reactants, the result equals the sum of the product's molecular weights. This complies with the conservation of mass principle. Please note there are 2 moles of both HCl and H2O in this reaction, so the individual molecular weights of those molecules must be doubled. Thanks for watching. If you enjoyed this video and want to see more like it, please like and subscribe. And to avoid missing out on new videos, please click the notifications bell. Have a great day.